Okay, 3 parts in this assignment. First 2 parts are going to be pretty easy, but the third part could be a little confusing. Find the value of each expression. The square root of 25. Now, this is called a radical, this little thing here. It's called a radical. With an index of 2. Okay, that means square root. 2 means square root. The second root, whatever you want to call it. It means what times what equals 25. It has to be the same factor. 2 of the same factor that equal 25. Is it 1 times 1? No. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. Okay? So this is equal to 5. Okay? Because it's 5. So you fill that in with 5 times 5. So 5 is just the answer. Okay? Whatever the factor is. Now the cubed root of 125. Now it's a radical with a 3. This means what times what times what, there's 3 of them, equals 125. Well, it's not 1, okay? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5, 125. So, fill those in with 5. The answer to this is just 5. Put equals 5. Okay, the fourth root is 16. It's not 4, because it's a fourth root. So it means what times what times what, draw out 4 spaces, times what equals 16. What was it, 1? No, 1 is always 1, but 2 times 2 times 2 times 2. If I put 2 in those, I get 16. So I fill them in. And the answer to this is just the number 2. Okay, the cubed root of 8. What times what times what equals 8. 3 of them. It can't be 1. 1 is always just 1. Okay, no matter how many factors there are. 2 times 2 times 2 is 8. So good. I fill those in with 2's. And the answer is equal to 2. Okay. Pause this video right now and go do 1 through 4. Pause it now and do 1, 2, 3, 4. And then join me back when you're done with 4 on the next page in the examples. Okay, this is fairly easy too. You have a fraction exponent. What's that's known as a rational exponent, okay? A rational exponent is the same as having a radical. What you're going to do is take out the rational exponent and write it in radical form. This is how you do it. M to the 1/2 power, that's a 1/2. First, here's what you do. You take out your 2, okay? And you put a radical over that M, and you put a 2 outside. And that's it. Write it without the scribble now. Radical 2 over M. You can put the 1 power. If the power is 1, you don't have to put it, okay? If it's not a 1, you have to put it. Okay, next one. Now I have a parentheses, or let's do this one, okay? 49 x to the 1/2 power. Okay, I put a times dot there. Now we get rid of the 2, but when we put the radical, we just put it over the x, okay? And we put a 2 outside. The 49 sits out there. So it's 49 radical degree 2, and then x to the first, you can just write as x. Now let's go up here. Now the rational exponent is outside of a whole parentheses. So now what I do is I put the radical over the entire expression. See here, there was no parentheses. The rational exponent belonged to just the x. Now the rational exponent belongs to everything. So I put the radical over everything. Okay. 2. So I put 2 parentheses 36x. And if you have a power of 1, you don't have to put the power. Okay, next one, another parentheses. That means the rational exponents to an entire expression. Okay, I mean, you can put a times dot, but still, you need to put the radical over the entire expression. Okay, and then you take the 3 out and put it right there. So you have a cubed root of 125x, and if it's a first power, you don't have to put it. Okay. Next, the rational exponent is not in a parentheses, it's to just the x. So I just put the radical around the x, I take out the 4 and just place it here. So I have an outside factor of 81, and then a radical of a degree 4 with x to the third. You do have to put the third power. Okay, you can't just drop the 3. Okay, 20a to the 1/3 power. So 1/3 is just to the a. Okay, so you put the radical around just the a. And the 3 goes outside, so you have an outside factor of 20 with a radical of a degree 3. Then a to the first would just be a. You don't have to. You can put the 1 power if you want. I'm not going to mark it wrong if you do, but it doesn't have to be there. Now the rational exponent is to an entire parentheses. So you put the radical around the entire parentheses with a 4 in the index, and that 4 now goes away. So we have a radical of a degree 4, and we have 16x. And then the third power has to be placed outside. Okay. 8y to the 2/3 power. So now the rational exponent belongs to just the y. So I put a radical above the y. I take out the 3. I put it. So I have an outside factor of 8. Then a radical of a degree 3. And then y to the second power. Okay. Now, that's fairly easy. Go to your assignment and please do numbers 5 through 11. Okay, 5 through 11. Remember, basically the only thing you got to pay attention to is whether the radical goes over just the variable or the entire expression. Okay, now rewrite in exponent form, then simplify. This is the hardest you'll have to work today. Here's what you're going to do. It says then you have to simplify. First, we're going to rewrite that as an exponent. So whatever's inside the radical, just circle what's inside and just copy that over here. Put equals x to the third. So my only base is x, so I underline its power and put a 4 underneath of it. So it's like I'm going the opposite direction. Now I simplify using my 3 lines. This one's not much to it. You have just an x factor. You won't have anything on bottom. Okay. 3/4 power. Doesn't need to be switched. It's positive. And I can't simplify it because it's x. If some of you know that's the answer right away, that's fine if you just put it. Now my next problem. First off, you got a radical. Okay. You need to put a 2 in the index. If it does not have an index number, you put a 2. Put a 2 if it doesn't have a that means it's an implied 2, okay? Not a 1. There's no such thing as a first root. You don't put a 1. You put an implied 2. If there's no number in the radical index, put a 2, okay? Now just circle the inside and just copy it over here. So now I have 2 bases, a 3 and an x. They're both to the 1 power. So we underline the 1s, but not the 4, just the 1s. Okay, if the outside exponent, we do not put that under. Okay, at least I'm not going to. And we put a 2. Now another way you could do it is just by underlining the 4 and putting a 2. But I think it will go better if you just put 1 powers on your bases and put 2s. Don't underline the outside. Now simplify it like normal. So the bases now we have are 3 times x. Well, they're both in parentheses, so 3 we take 1/2 times 4. Now I'm actually going to show my work over here because I don't want mixed numbers. That means I don't want like 1.5, okay? This isn't going to be 1. 1 times 4 is 4. 2 times 1 is 2. Now 4 divided by 2. Divide that if it's not a decimal. It's not a decimal, it equals 2. So this 3 would go to the 2. Then x, 1/2 times 4, I just did 1/2 times 4. That's also 2. So those come over here. Simplify your 3 to the second. That's easy. It's just 3 times 3. That'd be 9 times x to the second. Boom. Now, hang in there. Okay. Again, copy the inside of the radical. 27 times x to the third. Okay. So we have two bases. This would have a 1. There's no out, there's no parentheses here. So you underline each of them and put a 3. Okay. Now, 1 divided by 3 is a decimal, so we leave that 1 over 3. 3 divided by 3 is 1. Okay. See, if it divides not to get it into a whole number, like 3 divided by 3, you want to cross that out, put 1. Okay. So my bases are 27 times x. No parentheses, so it's just 1/3 and then 1. No, they don't change positions. We can simplify this, but here's how, okay? You've never had to simplify with a rational exponent. You are going to cross out your 27 and 3. Don't cross out the 1. What that means is the cubed root of 27. It means what times what equals 27. Is it 1? I don't think so. 8? No. 3 it is, okay? So you now cross it out, you replace it with a 3, and now it's 3 to the first power, which would just be 3, okay? 3 to the first would just be 3. That is now crossed out, okay? So we now have 3 to the power of 1. 3 times x to the power of 1. If you don't put the power of 1 on the x, that's fine, okay? Next, okay, copy the inside. Now it's got an outside power, but for now I don't care about that. These would both have 1 powers. Do not put the 4 under the, or by the way, that's a 2 right there. Okay, so you put a 2, then you underline them both and put 2. Okay. So we have 16 times x. Okay. So I take 1/2 times 3. I would put a 1 under the 3. And that would be 3 over 2. Still the same thing. This is why I don't want you just multiplying that on a calculator. That's 1.5. I don't want mixed numbers. You want to keep it in improper form. So 3 over 2. Then 1/2 times 3. To multiply fractions, just put a 1 under. And that's going to be the same thing, 3 over 2. Now, those do not need to change positioning. And this one gets simplified, but how? Well, we're going to get rid of the little 2 on bottom, so I'm going to cross that out, and I'm going to put 2 blanks, because it was a 2. It was a 2. Up there it was a 3, so that was 3 blanks, okay? The bottom number's a 2, so it's 2 blanks. It's like the square root of 16. It means what times what equals 16. It's not 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 16. So we found it, it's 4. So we replace that with 4, but we still have 4 to the third power, okay? Because there's still a 3 up there. It's not a 1 like this one was. So 4 to the third means 4 times 4 times 4, and that equals 64, okay? So this becomes 64. Times x to the 3 over 2 power. Okay. Next page. Let's keep it rolling. Okay, so I write 64 times, put a times dot, x to the second, no parentheses. Okay, so 64 would be a 1, so now I underline these and put the 3. Remember, if there's no outside number, you put a 2. But if there's it already there, you're going to put a 3 there. 1 divided by 3 is a decimal, so I don't put it. 2 divided by 3 is a decimal, so we leave it. Okay. So we have 64 times x. Neither of those are in parentheses, so we would just put the exponents that are there, 1/3 and 2/3. Bring them over. Basically, you don't really do anything from the first to the second. There's not going to be negatives. We can simplify this. How do you simplify it? Cross out the 64 and the 3, please. And that means I draw out 3 blanks trying to reach a product of 64. It means what times what times what? 64. It's the same as a radical. 1 doesn't do it. No. Bam. So this becomes a 4. So we still have the 1 up there. 4 to the first is 4, and then times x to the 2/3 power. Okay. Next problem. Okay. Rewrite it without the radical. Put equals. Just copy what's inside of the radical, the expression inside. 256 times x to the 3rd. That's 2 factors, 2 bases, so put a 1 there. You underline both base exponents individually, and you put a 4. So we have 256 times x. 1/4 and 3/4. Just bring those both over. They're both positive exponents. If it was a negative 1/4, you do your thing where you switch it. Now this bad boy has to be simplified. The base is 256. And the rational exponent has a denominator of 4. That's the same as a 4th root. So blank times blank times blank times blank equals 256. Is it 1? No. Is it 8? Nope. Nope. Bingo, 256. So fill in your blanks, please. And 4 is the number in each blank. So this becomes a 4. And we now have 4 to the first, which is 4, and then x to the 3/4 power. Okay. Next, copy the inside expression, x to the 6 times y to the 9th. Okay. Underline those both and put 3. But I think we can divide those because they're not decimals. 6 divided by 3 is 2. So if these are if these divide into whole numbers, do it. That's 3. So you have x and y. And you just have a 2 and a 3, no parentheses. Okay, now, neither one of them are negative, and neither one of them can be simplified. So it's just x squared times y to the 3rd. Okay, last problem. 81 times x to the 2nd. So I apply a 1, and they both have to be underlined, and they need to put a 4. Okay. 1 divided by 4 decimal, leave it. 2 divided by 4 is a decimal. You can leave it 2/4 or reduce it to 1/2. I don't care. Okay, so 81 times x to the 2/4 or 1/2. It's not going to matter either way. I don't care. Okay, bring them both over. And we can simplify him. So you cross that out, and what times what times what times what equals 81. Can't be 1. It's only 1 if you're trying to get 1. Nope. Bam, got it, 3. So 3 to the first is 3, and then times x either to the 2/4 or the 1/2. I don't care. Okay, now you're ready for the last part. I'm actually going to do one with you so you remember how it's done. A parentheses one. I want to do 13 together. 15 will be like 13. Because I didn't feel like prepared enough in the examples for a parentheses. Copy what's in parentheses. Remember, you put a 2 there. Okay. So we have you don't get rid of the parentheses. You put 2 times c with the 4th power outside. That means each of these are to the 1, and you put the 2, the 2nd root, under the 1. Okay? But we don't put the 2 under the 4, just the individual bases. So we have 2 times c. So I need to multiply here. I need to take, because out of the parentheses, so 1/2 times 4. 1/2 times 4, I'd put a 1 under the 4. 1 times 4 is 4. 2 times 1 is 2. Now, does that divide and not get a decimal? If it's a decimal, you just leave it and put it down here. But 4 divided by 2 is 2, so it'd be to the 2nd. And the c, that would be the same thing, 2nd. Okay? And then they stay where they're at. 2 to the 2nd, then is 4. You don't have a bottom exponent, okay? If you don't have anything on bottom, you don't have to do the blank, blank, blank crap, okay? You just 2 to the 2nd is 4 times c to the 2nd. It's when you have a fraction exponent where you got to simplify the bottom part first, then do the power, but I would just went right to my power there.